Good morning, everybody. Today we're going to talk about proving a parallelogram without coordinates. Some people might think, well, what does that mean exactly? So let's take a look. First of all, we need to figure out what the properties of parallelograms are. Okay? So in a parallelogram, opposite sides are parallel. And so what we mean by parallel is we mean that opposite sides will never touch. And we denote that with little triangles. My little triangles don't fill in very well, but that's okay. You get the idea. Alright, so we got opposite sides are parallel. Boom, check. Opposite sides are congruent. Means long sides are congruent and short sides are congruent. Check. Opposite angles are congruent. Let's go with my yellow. So we got congruent and congruent. Consecutive angles are supplementary. What does that mean? What does the word consecutive mean? Well, if we take a look at it, consecutive means next to or adjacent. Alright, so basically, what color am I on? Red? Alright. So we're talking about consecutive angles. We can talk about, I'm going to label my diagram here. A, B, C, and D. So consecutive means I can go A and B. I can go A and D. I cannot go A and C because those are not consecutive. We go around the figure. Basically, it's the next one. So we could say that A and B are supplementary. Now, what does it mean to be supplementary? What does it mean to be supplementary? Supplementary means two angles. So it's two angles that add up to what? What do they add up to? They add up to 180. You got it. So A and B, when added together, will equal 180. Or A and D, when added together, will equal 180 because they are consecutive. Or B and C, or C and D. Right? Any two consecutive angles will add up to 180. And the diagonals bisect each other. I think I have a line that's purple, so I'm going to try that. Line tool. And purple. Alright. Just to make it thinner, because I don't want hugely thick lines in the middle of this diagram, since it's already kind of weird. Alright. So when it says the diagonals bisect each other, everybody knows the diagonal goes from one corner to the opposite corner. Because obviously if it went from one corner to the consecutive corner, it'd just be a side. So here's what we mean when we say bisect each other. Let me find my pretty pink. Oh wait, there it is. Alright. Means that BD will cut the diagonal AC into two congruent pieces. And vice versa, AC will cut BD into two congruent pieces. So if I labeled this middle point, I called it E, we would say that BE is congruent to ED. And AE is congruent to EC. Alright. If you didn't get all that the first time, that's alright. We're going to go through it a little bit slower just to make sure that everybody's on the same page. But that's just a quick overview. So let's start over. Opposite sides are parallel. Alright? Now the question is, if we were just given this statement, opposite sides are parallel, is that enough information to say that this is a, oops, I don't want pink, I want blue. There we go. are opposite sides parallel enough to say it's a parallelogram? If all you knew about a shape were that the opposite sides are parallel, is that enough to say it's a parallelogram? Well, the answer is yeah, that is enough. Because if you think about it, what are the different kinds of shapes that we have? Let me throw them out here. We've got, oops, well, looks like we got two squares. And then we've got rectangles. And then we've got trapezoids. We've got a rhombus. And can't draw a kite with that, so I'm going to have to kind of freestyle kite. Yeah, shape recognition. Alright, let's see if we can get my kite going here. Oof, that's an ugly kite. Wow, they really don't like kites. Alright. I guess I'm just going to have to draw a kite myself without the fail pen. Alright, so it'll be a blue kite. Okay. So we've got our different shapes. And of course, obviously, we have our parallelogram. So let's take a look. Which shapes of these have opposite sides that are parallel? Well, by definition, we know that a rhombus has opposite sides that are parallel, because basically a rhombus is a parallelogram, except all the sides are equal. Okay? What about a trapezoid? Definition of trapezoid says we have one pair of parallel sides. Okay? The other pair, not parallel. So we know it cannot be a trapezoid. What about a rectangle? Rectangles have parallel sides that are opposite each other. Same thing with square. What about a kite? Yeah, kite, not really. So we've got four figures whose opposite sides are parallel. Let's take a look at the next property. Opposite sides are congruent. I really should have kept my shapes up there. So, think about it for a minute while I put all these shapes back up here. Square, rectangle, rhombus, trapezoid, and my fail kite. Alright. Opposite sides are congruent. Well, we know for a fact in a square and in a rhombus that all sides are congruent. So opposite sides have to be congruent. In a rectangle, we know opposite sides are congruent. In a trapezoid, no. We know the two sides could be congruent if it's an isosceles trapezoid, but we know that the top and the bottom not congruent. Therefore, again, trapezoid does not work. And a kite, consecutive sides are congruent, not opposite sides. So sorry, Mr. Kite, you don't pass the test. You're starting to see a little bit of a pattern here in this. Oh no, let's go to the next one. Opposite angles are congruent. Alright. So again, think about it for a second while I throw up all my figures again. not least, the old kite. Probably should just clone those. Oops, clone my marker. Okay. Opposite angles are congruent. What do we know about angles of a rectangle and a square? They're all 90, right? So that means opposite ones have to be congruent. They're all the same. So those two check out. Okay. What about a rhombus? Well, we said earlier that a rhombus is a parallelogram. It's just a parallelogram with sides that are all equal. So we know rhombus has to check out. What about a trapezoid? Well, the only thing we can say for certain in a trapezoid is that if it is an isosceles trapezoid, then the two base angles are congruent. But that's not opposite angles, so sorry, Mr. Trapezoid, can't help us there. And as far as a kite, kites have one pair of opposite angles that are congruent. So he comes close this time, but Mr. Kite just doesn't make it. So, and we got two more. All right. Consecutive angles are supplementary. So we talked about consecutive. We're talking about basically in order. So let me draw my shape A, B, C, and D again. In supplementary, they add up to 180. So throwing my shapes out there again. It's a big square. Rectangle, rhombus, parallelogram, and kite. Okay, so here we go. Consecutive angles are supplementary. And again, if we know that rectangles and squares have all 90-degree angles, any two angles added up have to be 180. So yeah, they work out. And again, our rhombus is a parallelogram, just with congruent sides, which means if it's true for a parallelogram, it has to be true for a rhombus. What about trapezoid? What do we know about trapezoid? What do we think? With an isosceles trapezoid, we know that base angles are congruent, but does that mean the consecutive angles add up to 180? Well, if we cut, that was a really bad dotted line. Alright, so we're just going to move that out of the way. If we cut our trapezoid in half, then, and again, this is only for an isosceles trapezoid, then these two angles would be supplementary. However, the two base angles are not supplementary. So Mr. Trapezoid comes very, very close again, but unfortunately, he can't seem to get, he's not part of the team. And
Mr. Price to the office, please. Mr. Price to the office.
yeah, well, apparently Mr. Price needs to go to the office. Alright, as far as the kite goes, we know that we have one pair of congruent angles, but we know nothing about the other two, so there's no way to say that those are supplementary and add up to 180. So Mr. Kite, again, does not make it. Alright, last but not least, diagonals bisect each other. Here we go. Apparently I've only got 30 seconds left, so I gotta fly through this one, but it's really not too tough. Yeah, tough. Alright, two diagonals, just like I said before. We're looking at, oh, come on, pink. Alright, bisect each other.